Okay, so this is the first video in chapter 5 FP2 about first order differential equations. We're looking today at integration by separation of variables, which is in fact something you'll come across again in C4, but we're going to cover it from the ground up, from first principles, so if you've not done C4 yet, do not worry. Before we get started, I just want to talk about what a first order differential equation is. It's not difficult to understand what that means. Let me give you an example here. So there's a first order differential equation. And what makes it a first order differential equation is it contains a dy by dx. The posh name for this, of course, is the first differential of y. And there you go, that's why it's called a first differential, because it's got the first differential in it. You've also seen, I think, a d2y by dx squared at some point. That there is called the second differential of y. And if you see any of those terms, it would be something called a second order differential equation, which is in fact what chapter 6 of FP2 is about. So we'll see it later, but for now we can just cross that out and forget about it. So let's have a look and see how we can solve something like this. Now actually this one here you can solve already. This is a equation you may come across in C1 or C2, and you can solve it by integrating both sides. Of course, if you integrate this side, you get y. And if you integrate this side, we have to raise the power by 1 to 3 and divide by the new power. So we get a third there, and we put plus c in because we've got no bounds. And that's it solved. So it's a very straightforward, very simple equation. But I would like to do it again, but this time do it a bit more formally, in the hopes that we can then get a method for solving more complicated differential equations. So let's just repeat that one again. This time what we're going to do is realise that we're integrating both sides with respect to x. So we're going to write the integral of dy dx with respect to x. So put an integral sign and dx sign up either side, and do the same thing here, integral of x squared with respect to x. Now we can do this side, so let's look more at the left hand side, see what's going on here. Can you see we've got a dx on top and a dx on bottom, so those two dx's actually can cancel out. This is the same as writing the integral of dy. Now this here looks a bit confusing. It may help if you imagine a 1 in there. What we're doing is we're integrating 1. Now we know we integrate 1, you get y. Okay, I suppose you normally get x because you integrate with respect to x, but because we're integrating with respect to y, here we're going to get y. And that's why when you integrate this side, it goes from being a dx, so dy dx, to being a y. Here, when we integrate x squared with respect to x, we raise power by 1 and we reduce, divide by the new power, and we get exactly what we got before. So it was the same thing, which is always good. The reason I've done it in this long-winded way, though, is because I want to focus on this step here. What we've really done, if you look at it, is we've taken the dx, and we've moved the dx here to get dy equals x squared dx. That's what we've really got there with integral signs in front of it. And this is called separation of variables. So let me just draw that 2 lines there. The kind of key point that I want to make is that, can you see what we've done? To go from this line to this line here, we just times by the dx. And what's good here is we have all the x terms on one side and all the y terms on one side, and then therefore when we put the integral signs in, this is an easy integral in terms of y, and this is an easy integral in terms of x. And this is called separation of variables. We've moved the y's all to one side and the x's all to one side. Everything's times together on each side. That we can then integrate. Let me show you what I mean by showing you some more examples. Some examples that we couldn't have done in C1 or C2. So there's another first order differential equation because of the dy dx term. This time we've got a y on this side, which makes it harder than sort of the C1, C2 equation we could do before. So we're going to use the same idea and move all the y's to one side and all the x's to the other side. Let's start by moving this y up to the other side, so by timesing by y. And now to get the x's, we'll times by the dx. So now all the x's on that side. At this point, we can integrate. Now the integral of y, dy, is just raised power by 1, divided by the power. Same thing here. It works because this side we integrate by y and this side we integrate by x, so it's like with like. So doing this side is just like doing this side here. And we're done. In fact, we could probably times by 2 and square root it to get into the y we want to. We're not going to do that today. We're not going to focus on that today. Let me show you a few more examples. The more examples you understand in mathematics, the better chance you've got of doing it yourself. Again, we're going to try and get the y's on one side and the x's on the other. So we always move the y's to the left. So we're going to take this y and move it to the left. Even though it's going to be it's at the bottom, we want to move the y's to this side and the x's to the other side. So the y's going to come across here. Scratch your head there. So now we pull the y down. Let's now times by this dx to get that there, and now we can integrate both sides. Now at this stage you may or may not know what the integral of 1 over y is. I think it's a C3 question, so if you've not seen it yet you'll see it very shortly, but the integral of 1 over y is actually in fact ln y, and so here this is going to be minus ln x. Don't worry too much if you've not seen these integrals because you will come across them. What we're focusing on is getting from here to here, getting to the position where you can integrate one side to y, one side to x, separating those variables. Getting the y variable on one side and the x variable on the other. We've got 2 more examples coming your way. Here's another one. Okay, so we're going to get the y's to this side and the x's to the left, to the right hand side, sorry. So we start by dividing by the y to get it on the left. Then we can times by the dx to get that on this right hand side. Then we can integrate both sides. Integral of 1 over y, well it was ln y last time, so it's ln y this time. And the integral of x, well we increase the power by 1, divide by the new power. It's all very straightforward. I've got one more example which is much, well it's quite a big leap in difficulty really. But just to show you where we're headed. This is also a first order differential equation. It's more complicated than the others. It's not dy dx equals, but it's still first order because it has a dy dx and no higher derivatives of y. So it doesn't matter if things are times by it. This is perfectly okay. Same tactic. Try to get all the x's to this side and all the y's to that side. But it's a little bit harder because of this term here. It's not easy just to sort of shift things around. The way I'm going to do it is by moving this to the other side first of all, taking y that xy, because that way I can factorise out the x. And when I've got this as a product of an x function times a y function, x here and a y bit here, it gets a lot easier to separate. You can't separate them when they're added on. It's very difficult. So here we have to divide by the 5 minus y. We're going to take this minus 1 minus x squared and divide by that. And this dy over dx, I'm going to times by the dx. So you may want to have a stop here and think about how I did that. Make sure you can do it. You can do it more than one step. I did about 3 things in that step. But once you're happy that that's okay, we can integrate that. Now the integral of this, again, maybe something you can or can't do. It's a bit of C3 integration. Here, if we differentiate this, we get minus 1, which is a multiple of the top. So we put that in and we divide by the multiple. In this case, we have to put a minus sign there. And here, this again, 1 minus x squared. This will differentiate to be minus 2x. So it's a multiple of the top. We have to divide by the minus 2. And then we get a ln of 1 minus x squared. Of course, plus c goes on the end. Again, if you can't do these integrations or these integrals, it's not that crucial. The important thing is, can you go from here to here? The integral should come with time when you do more C3 and more C4, and your integration improves just naturally by doing those modules. So at the minute we're worrying about how do we rearrange to get the x and the y separate, and then can we integrate them? It's a different question. So here, can you separate them, integrate them, and it's always going to get better over time. Anyway, that's how you solve first order differential equations by separation of variables. Get her a practice, and then I'll see you next time when we look at families of solution curves for these things. Until next time.